let us look at the last example before we get into the next section. So in this example, so you want to check whether the IQ of this population claim that the true mean IQ in the population is less than 100 justified. So you want to check whether the whatever the population this data is coming from, whether that mean IQ level is less than 100. So that's the null alternative hypothesis, and the null hypothesis is mu equal 100. Okay, so you have 12 data points randomly picked out of that. So n equal 12, and according to the question the sigma equal 12, that is given. Okay, so the normally distributed, it says normally distributed with variance 144, means that the standard deviation is 12. So so here is the initial population, so the x bar, and so this is normal, so therefore that n equal 12 is fine. So you have this is good. So under the null this is correct, and then this will follow the normal z curve. So this sample z is going to be the x bar minus 100 divided by the sigma, which is 12, divided by square root of n. So this value is going to be minus 1.1066. all right. So now the alpha is given, alpha equal 0.1. So here this is a one tail test, the lower tail test. So the rejection region has to be to the left. So this value is coming from the z table. So find from the z table, leaving 0.1 to the left is going to be minus 1.28. So this value is going to be right here, minus 1.106 is somewhere over there. All right. So that means, so this is the rejection region, reject H naught, and you cannot reject H naught at this region. So here this fall into this non-rejection region. So therefore there's not enough evidence to reject H naught and accept HA at alpha equal 0.1 level. So now the thing is that so here the assumptions, they are fine, even though n is small, initial population, they give you that is normally distributed. Also at the same time the sigma is 12, that is given. So by the way, so for this sample the average is x bar is that, sample standard deviation is going to be that. In other words, if you clear your memory, calculator memory, and punch those values, these are the two values you get. But the point is that since this is given, you do not use this value for this sigma. All right. So because you already know that value, this is just an estimate for the sigma. This one is just an estimate for that. So anyway, so that's part A, and part B, to find the p-value. So you set your cutoff right on that value and figure out the z table, the probability from the z table. So that's the p-value. So which is going to be 0.1335. So the part C goes very much the same way. State your decision using the p-value like before. So the way using this value, how you state your conclusion. If the alpha level is bigger than that, then you reject the H naught and accept HA. Otherwise, you cannot reject H naught. All right. So that's part C. The part D, if the normal assumption is not given. In other words, suppose this part from here to this part normally distributed, this part is not there, this part normally is that part is not given, still the variance suppose is given. Okay, So okay. So if everything except this normally distributed, can you do that question? So in other words, this is given except this part is not given. Okay, so the thing is that, so you have to have this part. You remember our assumption, so everything is based on that. So either based on the initial assumption or based on the sample size, you need to have it. So what you need to do is that if that part is not there, there's no any other way based on the stuff you know how to do that. So you do the exactly what we did, and at the end you say that the validity of these answers depend on that assumption. But the other way around, also you already have all the data. You remember that you know how to check whether the data is coming from a normal distribution. If you have a software, like if you R or the Minitab or whatever the software you're using, so you can use a quantile plot to see whether the data is coming from a normal population. Okay, so you need to check those things other words. But if you don't have the computer, like in an exam or something, so that way you cannot check that. So you need to write it down. Basically, the validity of your answer depend on that assumption. Okay, so that is a must assumption. In other words, this got to be a normal curve. So part E, if the normal assumption is given, suppose this normal assumption, this part is given, but sigma value is not given. This is not given. Okay? Not given. Can you do parts A, B and C? If this is not given, but this part is given. Alright? So that's the, so in other words, you remember that you do have all the data. So certainly you can figure out this. So the question is that, can I use that for that? You remember that in the confidence interval, we have done the theory part, okay? So that's what we are going to do next actually. So we are going to replace this thing by S. So the fact is that this is normally distributed. The minute you replace this thing by the sample standard deviation, this is no longer is going to be a Z curve, that will turn into a T curve. So we already did this one with the confidence interval. So in other words, this will turn into the T distribution. Okay? So in other words, you need to use the T tables instead of the Z table. So that's what I'm going to do next. Okay? But pretty much we have already done everything with the confidence intervals. Alright, so I'm going to kind of repeat it with the hypothesis testing, but instead of using the Z table, we are going to use the T table to figure out all of these. Other than that, everything else goes exactly the same way. Alright, so okay, so I will do that one in the next video.